let's look at perpendicular lines. We've already talked about parallel lines. Parallel lines are those that never intersect, okay? Well, perpendicular lines are those right angles. So think about those things like the corner of a desk, corner of a table, corner of a room, preferably two straight corners. They form right angles. Those are going to be perpendicular lines. Now, a line that is perpendicular to a plane is a line that is perpendicular to every line in the plane. So we have to be careful when we're talking about, like, here is our plane, okay? This line right here would be considered perpendicular to that plane because it is going to be perpendicular to everything in that plane. This line would be considered perpendicular to that plane. Now, this line right here is not perpendicular to this plane because it's going at an angle. Same with L and same with M. So the only lines that are actually perpendicular to any of these planes are actually the ones that are the intersections of these planes. So like this line is perpendicular to the plane alpha. This line is perpendicular to the plane beta. This line is perpendicular to the plane beta. These outside lines are perpendicular to the plane alpha. Okay? These lines right here are not perpendicular. So let's look at this. In the following figure, angle PBR. So that means PBR. This angle right here is 110 degrees. Angle QBS is 90 degrees. And the angle PBS, so the entire angle, is 140 degrees. You want to find the measure of this angle right here. Okay, so we know that this entire thing is 140 degrees. This is 110. This is 90. Notice that these angles have an overlapping angle. So this is in common. So if I think about this, okay, so 110, I'm just going to label this as X. So 110 minus X, or actually, yeah, and then 90 minus X, because 110 minus X will give me this piece. So this is actually 110 minus X. This is going to be 90 minus X. So if I take 110 minus X plus 90 minus X plus X, that should give me 140. total. But let's see here. Let's think of this another way, okay? This whole thing is 140. This is 110. So if I take 140 minus 110, so the whole thing minus this part, it should give me this part. So that would be 30 degrees. So that means that this part over here, just this little bitty part, would be 30 degrees. And if I take 140 minus 90, so the whole thing minus this part should give me this little bitty part. And so 140 minus 90, that would give me 50. So this part right here should be 50. So if I take and look at this and say, let me get rid of all this, because that's an ugly looking algebra mess. So if I take 110 minus the 50 and the 90 minus the 30, because if I take 110 minus 50, that would give me 60. If I take 90 minus the 30, that would give me the 60. So this is 60, which is what I'm looking for. So you have your entire angle, and you are having to solve the little bitty parts. And so you have to think about it, and there's multiple ways of solving that. Same thing with this right here. Angle AB and C are all adjacent angles that form a straight angle. So I'm going to draw, ooh, that's a horrible straight angle. So let's see here. That's a little bit better. So I have angle AB, no, I just need two of them. So let's say that this is angle C, this is angle B, and this is angle A. So A plus B plus C, we know is equal to 180 degrees, because it's a straight angle. A is 3/5 of B. So this is 3/5 of B. B is 1/2 of C. So here, I could replace B with a 1/2 of C as well. And so that would give me 3/5 times a 1/2 C plus a 1/2 C plus C equals 180, because all three of these added up will give me 180. So 3/5 times 1/2, that is 3/10 plus 1/2, 3/10 C plus 1/2 C plus C is 180. So that's going to give me 9/5 C is equal to 180. Multiply both sides by that denominator. So that's 9C is equal to 900. So C is equal to 100. So C is equal to 100 degrees. Well, 1/2 of C would be 50 degrees. Well, if this all adds up to 180, here's 150, so A should be 30 degrees. So A is going to be 30 degrees, B is 50 degrees, and C is 100 degrees.